We determined the maximum height that Sloth reaches in his heroic leap from the plank, about 30 feet up, by finding the change in height from events 1 to event 2, and then add in that 7.68 meters. That tells us that his height at event 2, y2, is 9.3 meters up. We don't know how far he went horizontally in that time. We don't know his x-coordinate here, x2, and we don't know his x-coordinate over here when he hits the water, x3. That's what we want to find now, his range, the distance from where he started to where he lands. So we want to consider events 1 and events 3 now. When he hits the water here, we know that his velocity will be tangent to the path at that moment. So his velocity at event 3 will look something like that. Let's draw in its components. We know that the x component will be equal to the x component of v1 and the x component of v2. That has not changed the whole time. And then here is the y component. We don't know what that is at the moment. So that's one of our unknowns right here. So let's reconsider our givens and unknowns for events 1 and 3. Okay. Given that we know the change in y position, he goes from y1 is 7.68 to y3 is 0, final minus initial, that's a negative 7.68 meters. Okay, we know his initial, we know the x component of his velocity from before, v1 cosine theta. We know his the y component of his initial velocity. That was his initial speed times sine theta. We don't know how far he goes from events 1 to event 3. That's what we're trying to find. We don't know how long it takes from event 1 to event 3. Okay, so let's go to our equations and see what we can do with this information. We want to find delta x here, so we don't know that right now. We don't know how long it takes. We do know Vx. Okay, so to get delta x, we need to know the time. So we'll have to find the time it takes over here by studying the vertical part and bring the time over. So we need one of these equations with time in it. How about this one? Do we know the change in the y components of the velocity? No, because we don't know the y component of his velocity at time 3. Therefore, we can't use that equation. How about this one? Yes, we know his change in y. We know the y component of his initial velocity. Don't know the time, don't know the time. There, we can solve that one because time is our only unknown. Let's do that. So our equation here will be delta y equals v1, y component, delta t, minus 1/2 g delta t squared. Okay, for vy, or for v1y, we can put in this information that is given. So we can rewrite this as delta y equals, and v1y is v1 sine theta delta t, and then this term remains the same. Okay, so we know delta y, we know v1, we know the angle theta, we know what g is. We don't know delta t here, and it appears squared here, so we've got a quadratic equation to solve. Let's rearrange this to get in a form that's easier to solve as a quadratic. Let's get all the terms on a single side of the equation. So let's move this term over to the left-hand side by adding it, and move this term over to the left-hand side by subtracting it. That'll give us 1/2 g delta t squared minus v1 sine theta delta t plus delta y is 0. Alright, so that is our solving, rearranging algebraically as best we can to solve for our unknown. Now at this point we can put in our values and attack it as a quadratic. So 1/2 g is 9.8. I'll leave off the units for now as we solve the quadratic. Delta t squared minus v1 is 8.41. Sine of theta is 42 degrees. That's meters per second there, but I'll leave it off while we solve the quadratic. Times delta t. and then our delta y is the negative 7.68 meters. Okay, so you got your coefficients here, A, B, and C for a quadratic equation. Solve that any way you like. You can use the quadratic formula here or graph it and find the zeros. What you should discover, no matter how you solve it, is that the only positive solution for delta t is 1.95 seconds. Almost 2 seconds he's in the air before splashdown. Now that we know delta t, we can go to the horizontal part and use this equation. Delta x is Vx times delta t. It's already solved for our unknown, so we can go ahead and substitute in the values. Delta x is, and Vx we can represent as the initial speed times cosine of the initial angle times delta t. So that's 8.41 meters per second, cosine 42 degrees, and then the time he's in the air, 1.95 seconds. And that's going to come out to about 12.2 meters. Remember, your conversion in meter is about 3 feet, a little bit more than 3 feet. So that's going to be approximately 40 feet. A tremendous 40-foot leap for the great and mighty sloth.